Thank you very much for the kind introduction, and I'm very honored to have so many people here in the room that there are not even chairs left, so there's one more down here. If somebody feels like sitting down instead of standing up, that makes it typically a little more relaxed to go ahead. So we're waiting for the slides. Here they are. Wonderful. We already have the title, so Connecting Cameras in a Future-Proof Architecture, and this is a little awkward. How many sessions have been in this room, been done in this room before? Is that the first session?
That's the first session.
The monitor is over there, the speaker is here, so that's a little, unless I turn around all the time, so somebody, we do a little redecoration, right? We already started with the chairs. Yeah, that's already better. Thank you. Yeah, so thank you very much. Yeah, thank you. Sounds good. So I always like to look back a little and also discuss where we are coming from. This is, of course, a lot of people here are really experts on cameras and imaging and know a lot more than I actually do. So please excuse that this will just be a snapshot and just my personal perspective on the matter, and it's not the core part of the presentation either. Then we'll discuss about some changes in the EE architecture, and then what it means to be actually, or what it means in my position and in my view to be future-proof. And of course we will also discuss technical solutions, and in particular I'll introduce the ASA motion link technology to those of you who haven't heard of it before. And I'll close with a summary and conclusion. So this is a little bit what it looks like for me, that digital cameras came, like many other things we have in the infotainment domain, also in cars, comes from the consumer electronics industry, so from outside of automotive. So we have the first cameras and the first digital cameras really a long time before it actually got widely adopted in cars. So we have the first use cases of having cameras in cars. The first one, let's say the first one with digital cameras, so with CCD cameras. Of course there were efforts before where they still were looking at more analog-based cameras. In '91, where Toyota introduced something, and then Nissan started with it in the year 2000 with a camera system that actually persevered for parking. And the first surround view system was in 2007, also from Nissan in this realm. And I have to say, and that's my, I take my hat off to the Japanese car manufacturers and everything concerning displays and visualization. They were quite ahead of many other car manufacturers in the world. What I wanted to show here is that the way from the first cameras being introduced into car to this being mainstream actually was quite some years. So even though it proved to be really practical, the backup camera, and that's why it got also then into legislations in the end, but even that it took many years. So we quite often face the situation where we see some inventions being there first, and then before it's being rolled out and before it gets really big, it takes many years. And that's in particular here for the camera applications, but of course it also affects everything else around the cameras, and part of that is the communication technologies used to connect the cameras. And while we're seeing it took a long time to pick up, now it's being mandated. And to go a little bit ahead of time, as a car manufacturer, we are facing different things being mandated in different regions. So Japan might mandate the side view for SUVs. The US was the first to mandate the backup cameras. Other regions have followed since then, but the EU also, for example, is the first to mandate the driver observation. So you have different types of cameras that you need to support in different regions. As a car manufacturer, you can actually choose. Do you make a different car for every region? Yeah, some people might say that's the right way, or others might say, well, we just put 6 cameras in every car in the future. And of course, working for BMW, we actually have the possibility to take such decisions in looking forward. When we look at how cameras actually function, I showed here that in 2023 there was about an average of 3 cameras per car. In 31 we are looking at an average of 7 cameras per car. We're also looking here at the resolution, and what is important for me, of course, the resolution increases. The megapixels get higher also for cameras in cars. At the same time, we're not selling for, we are selling for function and use. So we will typically use the amount of megapixels that we need to support a certain function in the car. We will unlikely put in megapixels a higher level just because we think the customer might actually know about it. It's very unlikely. I mean, I don't know, but I'm sure there are exceptions, but most people say, well, I want a backup camera system and I want a good image quality where I can see what's behind the car. They don't say, well, but it needs to be an 8 megapixel camera image I have. Yeah, they probably don't know. And that's the same, a little bit the same for the communication technologies. If you have a car, do you actually know how your air conditioning system works with your HMI, what communication technology is actually used in between? Do you care, or do you just want your air conditioning system to work and to be able to use it properly? Yeah, and that's to say a little bit the same when we go for cameras, which sometimes makes the discussion a little tricky on what we would like to see is the progress, and more is always better. We know progress always means more, so it means more megapixels, more everything. The question is whether that's really realistic, and whether you're not good at actually fulfilling your functions really well in with other resolutions. And to make a long story short here, part of that is what data rate requirements do I actually have on the link technology. And I've come to the conclusion that we will be very well served with 10 gigabits per second for a long time. And 10 gigabits per second for a camera is, I mean, that's video. In our complete car, if I put everything else together and in data rate that we have going through the car, we are well below 1 gigabit. Everything added up, and that includes radar communication and other sensors. So the overall amount of communication that you have is a lot smaller than the communication you have for a single camera, actually. So just to put that in perspective, and I think, again, most cameras will not even go anywhere near 10 gigabits per second for quite a while. I put here vision aiders and interior. That's how, well, some market estimates we had, I looked at, saw the distribution, and you see the share is mostly the largest part is the vision cameras, and that comes again from the regulation for the parking. Okay, with the number of cameras and with the cameras in the car, of course, we also had innovations around the camera and around the viewing that in parts also impacted the communication technology used. So The first cameras were to directly display what was being shown on the screen. So it was viewing. Viewing is what started cameras in cars. And of course, you wanted to have a better image quality, better contrast. And when you started with surround view systems, you also wanted to have a better stitching, where you had the overlap, so you had a smoother optical appearance in the car. And then, of course, a lot of people, you probably know that, and I really like that feature, is to have trajectories in your camera image, like where you put your steering wheel, that you actually know whether you're going to hit the curb or not when you go backwards. So I find that very practical. And of course, in some cases, you might actually get some highlighting of objects that might be in the way to additionally show what you're doing. And from the viewing, we're now also looking at sensing, which has different requirements also on what we're going to do. And with the sensing, we are looking at the increased resolution, the increased range for object detection, and a larger range of traffic signs that we can recognize with the writing underneath or whatever you have. And so that's part of putting it to sensing, and then we have the sensor fusion. And we've come from analog communication. There are still cameras being put into cars today that actually still use analog, that are connected via analog communication. We've moved to digital communication, and from there to using one of several proprietary service links, as they were the only ones that supplied sufficient data rates at the time this was needed. And part of that is also that the camera was not in the core, in the heart of the in-vehicle network. It was more, it started as a high-end function to the customer. And the high-end function today, whatever you need new, whatever you are urgent to put in the car, you're willing to make allowances for whatever you need to make it work. So you use whatever is available to make it work at that time. And then the sort of the innovations in those proprietary technologies, where there were several, so they competed with each other, and they made good progress in advancing data rates and other things. So now we're in the next phase, and that has been going on for some years now, and I think it will go on for another few years. That's trying to standardize the communication technology that has been used, and maybe even adding it more network capabilities or aggregation, integrating it into the zones, and I'll talk a little bit more about that. So the early camera systems were closed systems. They were bought by the tier one supplier that supplied the cameras and maybe even the processing unit that would look at the image, and then whatever the in-vehicle network was, that would be done. In the series production cars we are having now, or bringing to the road now, we have more centralization, and the cameras might be bought from a different tier one than actually the central ECU. And that's a little bit where it suddenly starts to get interesting for the car manufacturer, and where the car manufacturer suddenly thinks, ooh, if I have here a proprietary technology, I can never ever change the technology, even though I might want to exchange a camera at a different point in time than the main ECU. I want to update or just add another camera, and I sort of get a vendor lock-in on this. So still today, from what we're seeing today, we only have those technologies available to go into production today. So when we look at the future, the cameras still stay pretty much point to point in this scenario, and we'll start to see some zonalization in car manufacturers, centralization plus zonalization. And the zones keep the high data rate traffic out. In the future, that's interesting. Where we might go is we might see a mix of everything. Yeah, we might see a mix of cameras that go into the that are zonalized, that are aggregated, and so on. And the question is, how do we get there optimally? So if we want to have something future-proof, it means we need a sustainable security approach. That's very important. We need some flexible networking if we want to aggregate or anything like that. And of course we have this whole item of multi-vendor market, diverse product portfolio, competitive cost, and a maintained technology. And this is easiest to achieve if you go for standardization. It's not the only way, but it's the best way. Just to point out the security you have the link-based security, the layer 2 security, where you have the security starting and ending on one link. You have the red stars and the black stars which indicate that. And versus the application-based security, where you have one relationship end to end. And if you start having more than one processor that looks at the camera data, that's when it starts to get really tricky with end-to-end security approaches, because you don't only have to multiple times decode and handle your security, but you also have to then figure out how to do this actually with the key exchange and the like. So at BMW, we're pioneering the link-based security. We've done that for Ethernet as well, for our Ethernet networks, and we want to bring that to SerDes, and we think that's a really critical item to have. So we're seeing a number of efforts to standardize at the moment. We started with the proprietary technologies, and the standardization efforts haven't led to harmonization directly, as you can see, but we suddenly have a multitude of multi-gigabit standards in SerDes, and of course also in Ethernet, and there's a new project in 802.3 DM which is still open yet, and can yet decide whether they actually want to continue, whether they want to diversify further, or whether they want to help harmonizing the market. My opinion is that on that is relatively clear. If you think you add another standard for and think that will harmonize it, you will actually just add another solution to the market. It's very difficult to harmonize with an added solution, and I have to admit that was one of the experiences I had too. So that's almost the last slide. We're getting there. So the ASA Motion Link. ASA is Automotive SerDes Aligned. Motion Link is the technology that was developed, was founded in 2019, 150 members in May 2026. Of course, we have September. The number has increased by then. We have a number of specifications that with SerDes, it's always a little confusing. Often it's being sold by the line rate, 2, 4, 8, 12, and 16 gigabits per second, but actually you have only a reduced user data rate that gets over that line rate. So that's also written down here. You have the link layer security. You can do link aggregation in case you really need more data rate. And what's important to me, there is a possibility, there's an add-on that's called ASA Motion Link Ethernet, and that means you can use the same PHY and the same PMA and PCS principles, but you can have a different data link layer. So you can do the traditional SerDes approach with the SerDes data link layer, protocol conversion, and so on, or you can choose to maybe go via the Ethernet in case you want to go to the networking. BMW is planning SOP with this technology in 2027, and the rollout larger in 2029. So we have a booth where we show that technology downstairs. It's in one of the corners of the exhibition rooms. Look for the BMW logo, which is visible on the demo. And we have 8 cameras at the booth, and they have images from OmniVision, onsemi, Samsung, and Sony Semiconductor Solutions. We have physical layer implementations from 4 suppliers. Aviva Links, JL Semi, Microchip, and also Sony Semiconductor Solutions. We have 2 SoC concepts that we are showing that connect to this. One, the NVIDIA Orin and the Qualcomm Ride. We have different product types. We have the single serializer, single deserializer, quad deserializer, and an aggregation with 3 deserializers and 1 serializers. We have also a BMW display just to make sure there's some BMW in the demo as well. And of course, we also have a control GUI for handling the images on the display. And coming to the conclusion, so the introduction of automotive cameras is a result from the consumer industry. Yeah, it's one of those technologies that trickled from outside into the car, and it started as low volume, high-end options, and they were presented or sold as closed systems by one tier one. And the communication system at that time was a necessity, but it wasn't in focus. It was something that simply had to work and then had to function. Now we're seeing a surge in the number of cameras that we will have and in other regulative requirements that lead to that. And that also impacts the need and the requirements we have for the communication technology. In addition, the architectures are changing, and we want to change and be flexible in the architecture in the future. And with that, next to ensuring a robust communication technology, a standard has to be, fulfill a number of other items. And one is a sustainable security. It's flexibility in the networking that we can have. Of course, we want to have interoperable, diverse product portfolio available. That's why you would like to have a multi-vendor environment, competitive cost, and with the standard also to have a technology that's maintained and being improved. And of course, ASA Motion Link is a technology that meets those requirements. Otherwise, we wouldn't follow it if we hadn't ensured that it actually meets what it's supposed to do. And with that, I'd like to thank you for your attention. And I have to do this advertising. I apologize. The book on automotive high-speed communication, this is what it is. It covers specifically all the elements that go into automotive high-speed communication for sensor and display application. And as said, I always like to not just say how, but also why in those books. The other one is the automotive Ethernet one.
Good. Thank you. No problem with that advertisement. That's good reading material. Thank you, Kirsten. So, as one good news, I asked for about 10 more chairs. Not sure where we put them, but we'll see. So we'll hopefully get some more chairs in here in the center. We have room for about one question. Anybody has a question they want to ask? You, Art.
Thank you. Could image compression change the game in the EE architecture for the future?
Image compression can only change the let's say, if that really leads to a reduction of data rate, it could accelerate the adoption of zonalization. But only if it really leads to a reduction of data rate. Otherwise, you have one of the items you have right now, you can have your zone, and you can add 5 more CAN buses to your zone, and it makes no difference for the aggregation. You add a single camera, and the data rate you need on the backbone explodes. Yeah, so if you really manage to have transmit less data, you might see that earlier. Right now, I would say you have the aggregation in case you run out of. You have other problems like too many connectors. You need to save connector space, or you have 3 cameras in the door, and suddenly your door connector gets filled up, or things like that.
Very good. Thank you. So Kirsten will be around for more questions throughout the day, and visit the BMW booth. And I have this already in my Amazon reading list for going forward. Thank you, Kirsten.